we were talking about cardinality, and remembering that cardinality was this was establishing the associations that were done with the relationship and seeing how these associations were with regards to the amount of entities that are involved. So we already mentioned that there were three main types of cardinality: one-to-one, one-to-many, and many-to-many. And so we were talking about these exercises here that had to do with trying to identify cardinality for these situations here. And I believe we had already done the first one. Students learn from faculty. So we had said that this was an N to M relationship, because many students can learn from many faculty. Many faculty can teach or many students. And then we were talking about clients and contracts. And remember that there could be many situations for clients and contracts depending on how we interpret the situation. So clients and contract, there could be one client having to do with one contract. That could be the case maybe of we mentioned like an NDA, a non-disclosure agreement between a company and a person. Oh, that's one person signs one contract. That contract is for one person. Then it could also be a one to many, where one person can sign many contracts, but each contract is only signed by one person, so that's a one-to-many relationship. And we could also have a many-to-many relationship here, depending on the situation. An example of a many-to-many, for example, is a marriage contract. So no, I'm sorry, that's a one-to-many as well.
Real estate, or
what?
Then you said last class real estate, right? That was a many-to-many.
Which one? I'm sorry.
The real estate, or
Oh, the real estate. Yeah, the real estate example. Yeah, the name was mentioned. So realtor can have many contracts. A contract may be negotiated by many realtors. So depending on the situation is how the cardinality is going to be. That's why the analysis part of the problem or definition of the database is very important, because that's going to give us specifically which of these we're going to assign depending on the situation. And it's very important to assign these correctly, because these are going to be part of the definition of the database. And as we mentioned, the one-to-one and the one-to-many are much more manageable in the database implementation than the many-to-many. The many-to-many generates more complexity. So ideally, we would like to have or not have many-to-many relationships. And so now let's see two entities: that employees and projects. Okay, and there's two possible relationships there. Employees work on projects, or employees manage projects. How would that relationship? How could that part?
I feel like it could be also like a one-to-many, because one, like an employee, there could be a project, but only one employee manages the project.
Mm-hmm.
And the one with the employees would be, there's a lot of, I think I mixed up stuff. A lot of employees, no, yeah, a lot of employees can work on one project.
Mm-hmm.
But the project can only be managed by one employee.
So the work on and the manager are a bit different, right? And depending on if we're talking about working on or managing is how we can approach it.
So the project can have many employees, but maybe I am a manager. So I am working on many projects as well. I delegated a lot, so I need to be supervising all of those.
You can supervise more than one. So in this situation, an employee could work on many projects, and a project can be worked on by many employees. That's one situation. It could be an N to M if we wanted it. By the way, be very careful if you're in an organization that has to do with employees and projects, and the relationship between those two is end to end, because that means that you're going to be working on a lot of projects at the same time. And the projects that you're going to be working on are going to be working on by diverse people, and that's a complex situation. If the organization is very well organized, that's fine, but if not, that can be really a headache. So it could be many to many. An employee, there might be another situation where I, as an employee, can only work on one project. Okay, I can only be assigned to one project because that's the way the organization works. I can't be on many projects. I have to be assigned to one, but a project can have many employees. So this could also be, depending on the situation, a one to many. And that also has to do with what Daniel was mentioning, where I can have, I can manage a project, and I can manage or supervise many projects, but each project can only have one supervisor. Okay. Okay. Now, clients and credit cards, or charges on credit cards. Notice that there I am using the word client instead of customer, because even if we're just one person, for a bank, if I have a credit card, I'm a client of the bank. Because I'm using or have a contract for a specific service, and a credit card is kind of like a contract. So a client can own or make charges into a credit card. How would that relationship, or the cardinality for that relationship be?
So you could have one to one, no, one to many, because maybe the bank has another client, a lot of clients. But it can also be.
Well, we're talking about the credit card, a specific credit card for the bank.
That's
One too many.
Want to explain a little bit about the rationale?
Because there's only, you can only, let's say you have one credit card, but with that credit card, you as a client can make multiple charges.
Mhm. I can make multiple charges. If I'm looking at the charges as a whole, then I, as a client, can make multiple charges, but those charges in the credit card are associated to myself.
Or
Okay.
maybe one too many, because maybe I'm an expert estafador, and I have one credit card, and then I get another one to pay my debt on the other
And
one.
the other one, yeah, that's a kind of like a scam that can be done. But by the way, that's not a sustainable scam, by the way, because the only thing you're going to be doing is moving the money around, but in the end, both credit cards are going to be,
You owe money.
you're going to owe money in the end. But there's people that live like that, actually. So it could be one too many if we see it that way. Another way of looking at the clients and the charges is if we look at a specific charge, okay, in the credit card. Let's say that, Jesus, you have a credit card and you buy something in Mercado Libre. You buy a Blu-ray or something in Mercado Libre, and that costs 800 pesos. So you do that with your credit card. You are doing one charge, but that specific charge in Mercado Libre is associated to you, only to you, because you're the buyer. So it could also be, depending on how we see it, it could also be one to one if we look at the charges individually. If we look at the charges as a whole, it might be one to many. Books and users, books and users in a library. We have many books in a library. There could be many to many because a person can read many books. There could be many editions of a book in the library that can be read by more than one person. Okay.
Sure. I have a question.
Yes, go ahead, please.
Is that order of the entities correct? Like, wouldn't it be the other way around, like users read books, not books read users? Or like,
Yeah, that's a good observation. That's a good observation. And that's actually correct. That is actually correct. We could do a couple of things here. That's actually correct. We could flip these. Yeah, we could flip these. Oops. Or we could change the relationship, but yeah, you're right. This is true. Good observer, good catch there. And this, oops, I'm looking at this here. So one thing we could do is that, which is to just flip. Or we could have changed the relationship. We should, books are read by users. But yeah, that's a good observation. Good catch there. Good catch there. Clients and cars.
Clients and cars.
It could be clients or customers there.
Would
depending
it
on
be the same as the library, the books?
Or you can have, can you use the car of your mom?
Well, that would, well, we're talking here about a rental, like a car rental service.
So it is.
Um,
So that would be one-to-one.
It could be one-to-one. If we're talking about a specific car can only be rented by one person. Depending on how you establish the policy is if a person could rent more than one car.
Well, then it would be a company, because if you were trying to rent a car all by yourself, don't they ask you like who's going to drive it?
Yeah. So if we're looking about a normal rental and it's client again, because the rental of a car is also something that generates a contract. If I'm going to a rental space, a rental company and say, I want to rent a car for the weekend, the car has to be assigned to somebody who's going to drive it. If I say, you know what, I want to rent 3 cars, at least in my experience, it's not going to be a situation where the 3 cars are going to be under my name, because in theory, I'm not going to be able to be driving the 3 cars at the same time. So each car would have to be assigned to a person. So under that situation, it could or should be one-to-one. If we were talking about more of a corporate rental, that might be different, because the corporation might rent 3 cars and have 3 drivers assigned to it or something like that. That situation could be one-to-many. Okay. The more typical one would be like just the interaction between any of ourselves and a rental agency would be more one-to-one. Faculty and courses, we had already talked about this one. Well, we talked about students, but it's the same thing. This could be N to M. A faculty can teach many courses. A course can be taught by many faculty. By the way, we're going to be seeing this when we get more deeper into the design of the database. But right now we're talking about courses. So for example, a course is data analysis and organization. That's a course in an academic program. That course can be taught by many faculty. Okay. And a faculty can teach many courses. However, the end-to-end relationship we're going to see is going to generate a new entity. And the courses and faculty is a good example of that. A course is data analysis and organization. The faculty is the 3 or 4 professors that can teach that. So many professors can teach this course, and courses can be taught by many professors. However, how am I going to differentiate then that this data analysis and organization course is taught by Jorge Sosa to the global programming group versus the data analysis and organization course that's taught by, I don't know, Francisco Chavez to the non-global program group? How am I going to differentiate?
How?
Yeah, so the course is named data analysis and organization, but there's more than one group of that course.
Oh, okay, classroom.
And actually, I just said the response. They're differentiated by a group and a classroom. Okay, the group in the classroom is what differentiates this data analysis and organization course that's taught by Jorge Sosa from the other data analysis and organization course that's taught by somebody else. That's the thing about the end-to-end relationships that we're going to be discussing eventually. The end-to-end relationships have to generate another instance in the database that is able to relate them. The end-to-end relationship between faculty and courses is related by another attribute that is actually the group in the classroom, or a couple of attributes, which is the group in the classroom. And so that's something that we're going to note when it's an end-to-end relationship. Okay, questions with this before we jump on to talk about something else related to this. Questions over at home. Are we good at home? Any questions at home? Reactions at least. Are we doing good? Any questions? No? Okay. Remember at home, if you have any questions, just jump in. Okay. Let me clear drawings here. Okay, now something that's also going to be important in cardinality. Right now, we're talking about one-to-one, one-to-n, end-to-end. And the n's and the m's are these sort of abstract variables. But it's also going to be important for us to identify the minimum and maximum values that we can have for these. So whatever we store in the database makes sense. So let's talk a little bit about that. We've got three entity relationships there. So the first one, employees have children. What type of relationship would we have there? One to many. It might be debatable if it's many to many, assuming that a child has more than one parent. However, the way it's actually deployed when we're talking about employees and children or parents and children, usually regardless of if the child has one or two parents, usually one of them is designated as the tutor, okay, or is designated as the official one. So I'm going to say this, I don't know the specific situation, but I imagine, for example, if you have a company and you have two employees in the company that are married and they have a child, the insurance is going to cover the child, but you're not going to duplicate the insurance for each of the employees. Is that understood? Does that make sense? So, for example, Arturo, you're working for a company, and you're married, and you have a child. So you and your spouse both work for the company. The company gives you insurance. So you have an insurance policy that's under your name, and your spouse also has an insurance policy. Okay, both of you have your insurance policies. If you get sick, if you break your leg or whatever, your insurance policy covers you. If your spouse gets in an accident or needs surgery, they have their insurance, and the company pays for it. Usually the way that works is that when you have a child, you can, instead of you having to buy another insurance policy, you just add your child to your company's insurance policy. I just did that. So, but if you and your spouse, both of you work in the company, you're not going to necessarily add the child to both insurance policies. You're going to probably add it to one of them. That's why even though a child can have more than one parent, right, you usually assign one of them as a tutor. So the relationship that would make sense here is a one-to-many relationship. By the way, that thing about the insurance policies, we're really, things in the world in different countries and all that, but we're really in a relatively privileged situation here in Mexico, like other countries, that most companies offer insurance policies for their employees, and even we've got the Social Security and all that. But I talk a lot with friends of mine that are from other countries in the United States, and particularly Dr. Dan Shunk, and we're talking about these sorts of benefits and all that. And I'm mentioning surgeries. Okay, so I had 2 hernia surgeries and I paid I think $200 in total for both surgeries. And he's telling me if I were to have 2 hernia surgeries in the United States, that would be thousands of dollars that I would need to pay. And so having these insurance policies, it's really a cool benefit. When you going back to the discussions that we were having last class, Marco, about the degrees and looking for jobs and your CVs and all that. It's very important when you guys look for a job that the company is interviewing you, but you're also interviewing the company. So getting to know what benefits the company gives you is really important. So you might have a company that's offering you a very high salary. You're like, yeah, I'm going to go there, but the company isn't offering you insurance. There's another company that might offer you a little bit less salary, but they're offering you insurance. You have no idea what that is. You have no idea how important insurance is until you need to use it. And you need to pay for things if you don't have it. So keep that in mind. But well, okay, we've got employees and children. So it's a one-to-many relationship. Now, if it's a one-to-many relationship, now I'm going to ask you guys, if I look at N, what could be the minimum and the maximum value of N? And I want to mix up the participations here because this seems to be the Daniel and Marco show, and I really appreciate them participating, but I want to get more people involved. So let's see. Aime, are you there? Could you please turn on your camera briefly? So Aime, if we're looking at the cardinality there of employees and children, and we say that it's a one-to-many relationship because an employee can have many children. But now we look at the N, which is, well, how many children can an employee have? What do you think would be the minimum value of N and the maximum value of N?
Minimum is 2.
Could you say that again a little bit louder, please?
I think the minimum is 2.
Let's talk about the minimum a little bit, okay? And let's talk about that perspective. So the minimum amount of children that any employee should have is 2. Right?
I think so.
Really? No, that would mean, just to clear it, that would mean, that if I'm working for the company, I need to have at least 2 children.
I don't know if the employee has one child. It's, I don't know, it's 1-to-1. No?
No, if let's say you're working for, right now they hire you to work for a company. How many children do you have?
I don't have.
Can you say that again, please?
I don't have child.
You don't have any, right? So what is the minimum amount of children that an employee can have?
0.
0, exactly. So think about that. If I say the minimum amount of children that an employee can have is 2, that means that if I'm going to hire someone, they have to have 2 children. That doesn't make sense. The minimum amount of children that an employee can have is 0, right? Does that make sense? So maybe somebody doesn't have any children, and that's fine. So the minimum would be 0.
No, because
No, because again, imagine that I'm hiring you for my company. If you say that the minimum amount of children that an employee should have is 1, that means that you should have at least 1 child to work for me. It's so you're an employee in the company. What's the minimum amount of children you could have? Well, 0, right? What's the maximum amount of children? That's a trickier question. What's the maximum amount of children that we could have? I mean, what do you think? What could be the maximum amount of children?
I don't know. It depends on the person.
Correct. It depends on the person because Marco, it depends on the person. I mean, you can have as many children as you want. There's a thing there that if we're talking about an organization, we do have to think about that. Let's see.
wouldn't it depend a bit on the company, because if they're hiring people with children and they're offering insurance, or I don't think that if someone has 20 kids, I don't think they're gonna offer insurance for 20 kids.
Yeah, probably, that makes sense, Marco. Probably if this is related to insurance policies and benefits, probably there is gonna be some sort of restriction as to the amount of dependents you can add. Okay, so there is probably gonna be a maximum, okay? Mia, you wanted to say something?
No,
Okay.
I want to say something, maybe because of the insurance and that many.
Yeah, you can't have an infinite number of children. Probably the insurance is gonna limit that, because the other thing that again, I don't think you guys think about these things, but for example, you can have an organization that gives you a certain benefit, and then somebody says, you know what, I'm gonna adopt my friend's child just so they can have that benefit. And so insurance policies and benefits are protected against those things. Or else, like you said, Marco, I'm gonna adopt 20 children to give them. For example, a benefit that we have here at CETIS is that if we're a full-time employee, our dependents can study here with 100% scholarship. So my wife and my children can study here, let's say this, for free. So then what I'm gonna do is I'm gonna adopt. So does anybody want a scholarship here at CETIS? Okay, do you want a scholarship? I'm gonna adopt you. So now you're gonna be my kid. And so the benefits in a company don't work that way. You can't have 20 people that you're gonna add. So the maximum is probably gonna be a certain value, okay? Right now, we don't know that value, but let's assume that the policy for this company is that the maximum amount of children or dependents is 4, okay? Just to put a number, okay? I mean, does what we're talking about make sense? Is it a little bit more clear now? Okay. Thank you, Amy. Students in classes. We had already talked about that a student can take many classes, a class can be taught by many students, so it's end to end. But now let's look at the minimum and maximum for N and for M. So N is for students. What is the minimum amount? And let's just, there's actually some fixed numbers for this in policies. But let's think about that. What is the minimum amount of students for a class? What could that be?
Isn't it 10?
Usually the parameter is 10 here at CETIS, Daniel, and the reference for that is for opening a summer or winter course. Usually the minimum has to be 10. For a normal course, depending on the situation, we might have less than 10, but let's assume it's 10. Yes.
I was going to ask about that. For example, if you're in the Google program, we're like 16 or 15
Mhm.
in our generation of the career.
Mhm.
What would happen if there's like just 5? Will the course still be open?
Oh, yeah, that's a very good question. That's a very good question, Marco. Actually, the way it works, I'm gonna bring this over here because I don't wanna.
Or could you have like a one-on-one, like one teacher, one student in the Google program only?
Well, actually, that has happened
Yes.
before, and it can happen in a university. Not just here at CETIS, by the way, and that's actually an issue in universities, and it has to do with academic planning. So I'm gonna say it this way. I am offering an academic program here at CETIS or wherever, and I open it. And when I open it, I get the minimum amount of students for that program. Let's say I'm going to open the global. When we opened the global program a few years ago, our goal was 20 students. We got 22. If we had gotten less than 10 students, 5, we wouldn't have opened the program. Okay, so are we good up to that point? So when we open the program, we have to have a minimum amount of students, okay? But let's say that we get 20 students. Or you guys, I think you started out being 17 or 16 or something like that. Let's assume that after this course, you guys are so fed up with engineering after this course that at the end of this semester, you say, oh, the data analysis and organization course was so boring, so bad that I want to change my academic program. I'm going to change to psychology. And of the 16 of you, 9 of you changed to psychology, and we're only left with 5 of you. Are we okay up to this point? We have to offer the complete program for the 5 of you. So that's actually, so if I have one student enrolled in a program that I offered for that student, that's kind of like a contract. I have to fulfill the whole academic program for that student somehow.
So if he will graduate by himself, so it's like.
We've had that situation, we have those situations, like you guys are in a big program, but here at CETIS, the industrial engineering program is the largest program. Then we've got mechanical and mechatronics. Those represent about 66% of our population, but we have other academic programs that have less students. So yes, we've had, not now, but I remember graduations where we've had 1 or 2 students graduate from a program. That can happen. So it's a contract. I mean, it's just not just here at CETIS. That's actually an issue in universities about students dropping out. So you might have a program where a lot of students drop out, but we made a contract with the students that are enrolled. So if 70% of the group leaves, I can't just say to you, you know what, the rest of the group left, choose something. I can suggest that you choose something else or give you alternatives, but I can't just close the program. That would actually be kind of like a breach of contract. You could technically kind of have a situation there with the university if the university does that. So yeah, if there's one student in the, right now, these are good times for CETIS with regards to students, but I remember many years ago having classes with 3 or 4 students in a group. It's not as fun, obviously, but let's imagine a normal situation. What would be so the minimum of students, let's say that the minimum of students is 10. What could be a parameter with regards to the maximum amount of students there?
Maximum, isn't it? Like 30 something.
It would depend, right? Even right now, notice how these things change. The reference could be around 30. But right now, if we're talking about the pandemic and social distancing, even that changes because it has to do with the capacity of the classroom.
Yeah, I remember in high school it was 35.
Let's assume that it's pre-pandemic. Let's assume that it's, I'm gonna say 28. Go ahead.
The 2 pandemic would be like 15 or 16, right? I'm pretty sure like the whole group, like all of us could fit in one class.
I think that here it's 1, 2, 3.
8. We're 8 right now.
I think it's around 16 in a classroom like this one, 16 or 15, something like that. It would depend on the capacity restrictions. So the minimum amount of students would be 10, the maximum 28. Now, with regards to the classes, what is the minimum amount of classes that a student can take? Jorge? 1. It has to be, the minimum has to be 1. It can't be 0 because if you're taking 0 classes, you're not a student.
But here I think we can only take 1 class.
It could be the situation that Marco is mentioning. You could be a student that went on an exchange program, and for some reason, you couldn't take 1 course. So we have students that are taking 1 course just to finish, for example. So that could happen. So the minimum should be 1, and the maximum, according to our policies, the maximum, I think, without you guys needing to have some sort of special permission from your coordinator is, I believe it's 6.
6.
I mean, we've had students that take more than 6 courses. There's these kamikaze students that take 8 courses, or, I mean, it can happen, but you need a special authorization. But let's say that the maximum under normal circumstances would be, let's say that it would be 6.
By special authorization, you mean like you need to make a test or like or something?
No.
And you can handle all those courses or?
No, what happens usually is that, remember that you guys can enroll by yourselves on the internet. So if I'm not mistaken, the way it happens is that the system has a restriction. So if you select 7 courses, it's not going to let you select 7. To select the additional course, you just have to just send a letter to your coordinator saying, I want to take this other course. And unless you have any sort of academic block or something like that, then the coordinator approves it and you can just take it. You don't have to take an exam or anything like that. There, on the other hand, there are students that have academic blocks that are limited, that can't take more than 3 courses or 4 or something like that. Because in the end, the idea is for you guys to take the amount of courses that you can manage or handle. Okay. Questions with this, with the minimum, we're gonna do one more. Okay, so that's the students. Oops. So that's the students in classes. And now the last situation here that we're gonna see is, let's look at a sports scenario. So we've got teams. I'm using the example of the NFL just because I like the NFL and I know it a little bit better than other sports. So we've got NFL teams play games, and these games are the complete games that they could play, including the playoffs. And so first, how would that cardinality be defined between teams and games, teams playing games? Many to many, because a team can play many games. A game is played by many teams or has to be played by many teams. So it would be many to many. Looking at the minimums and maximums over here, if we were to be talking about the teams and the games, in the case of the teams, what would be the minimum amount of teams that are required to play a game, and what would be the maximum amount of teams required to play a game?
2 and 2.
2 and 2. We have to have at least 2, and we actually can't have more than 2, so it would be 2 and 2, minimum and maximum. Now, with regards to the games, what would be the, and again, if you follow the NFL, you might know. If not, then I'll fill in the gaps. But if we're talking about games, what's the minimum amount of games that a team can play in the season?
17.
So with the new format, it's 17. What would be the maximum amount of games that a team can play under the new format? If assuming that they play the Super Bowl.
That would be 21.
Probably 21, because it's if they are a wild card, they would be wild card, then the divisional round, then the conference championship, and the Super Bowl. It'd be 4 more games, so the maximum would be 21.
Does the preseason count?
Well, for the
There's no games. So
if we were to count the preseason, I think there's 3 games in the preseason. If we count the preseason, then didn't they? There used to be 4, but didn't they reduce the preseason? I think so. The minimum, if we include the preseason, the minimum would be 20, and the maximum would be 24. If we include the preseason.
And if the case, what's the Pro Bowl, not the Super Bowl?
Mhm.
How would that work? Because there's multiple players from different teams.
Oh,
making one team.
That's a good observation. I would contextualize it this way. I wouldn't include the Pro Bowl because the Pro Bowl isn't played by teams, it's played by players. Right? So it isn't necessarily, so all of the teams put players in the Pro Bowl, but they form 2 teams. So but the teams in themselves don't play the Pro Bowl. Okay.
Hall of Fame team.
It would be a similar situation. So the Hall of Fame team is comprised by, but those are those ex players?
No, they
For the
play real players.
The real players.
It's like
Um,
an extra preseason game.
Yeah, it would be but is that played by different players from different teams as well, right? Or is it
It's 2 teams.
it's 2
Like,
teams?
For example, this year it was the Steelers and Cowboys, I think.
Mm.
I'm not sure.
If it's now, that's a good example. If that game is included in the statistics of the teams, because in the end, why would we be interested in this? Because we might want a system where we present statistics of games played, and et cetera. If it would be included in the statistics of the team or of the information that I want to present, then we would include it, if it would make sense. I believe that certain statistics of teams and players and have to do with regular season games. I don't think, for example, the statistics that we present about a team, the total offense, total defense, et cetera, I'm not sure if the preseason games are included.
No, they're not.
And I'm not I think the postseason is included in the statistics or the data, but not the preseason. Okay, so these would be examples as to how we would define cardinality and define the minimums and maximums. Now, the minimums and maximums are important because we can actually define these in the design of the database and the deployment, and also to be able to make sense or whatever we store with regards to the structure of the database and the data for it to make sense. Okay, questions? Questions with this before we move on? Okay. Now, continuing the steps that we're following in the design, the next step is to establish attributes for each entity. And we already talked about that. The attributes are going to be these things that describe the entity, things that make sense in the description of the entity. How many attributes an entity has, that depends on us. We can define as many as we want. The only thing here important is to, first off, identify and define the attributes that we need. I'm going to say it this way: define and identify the attributes that we need, and think about the attributes that we might need, maybe in the future. We want to try to not add attributes that really don't contribute or are just making the data larger, but they're not going to be useful. So keep those things in mind. We want to define the attributes we need and the attributes we might need. Oops. So we'd already talked about this. These attributes are going to describe our entity. They're going to represent characteristics of it, these properties. And so, for example, if we've got students, what are some attributes? Your student ID, your name, your address. Remember that we talked about what's an attribute that makes sense? The birth date, not the age, because the age changes. The birth date is fixed, and I can calculate the age based on the birth date. Okay, those are some examples of attributes that you guys might have that might be of interest. Okay, what other attribute? Maybe I want to store your group as well. I don't know.
If there were to be attributes that have to be fixed. No, or
Well, that let me see if I understand your question or do it so it's informal. So when you're saying fixed, Marco, meaning okay, I define these attributes, I design the database, and I can't add any more.
no, I mean like you said, it's a birthday, not the age, because the age can change.
Oh no, if you wanted to, you could put the age as an attribute. The only thing I'm saying is that so no, it doesn't. They don't have to be fixed. I'm just saying that when we think about attributes, you might be saying, what I want, I'm interested in the age of the students. And you might think, okay, I'm going to put an attribute as the age. But the birth date makes more sense because you can calculate the age based on the birth date. Or else I might, an attribute might be the age. How old are you right now? 18. So right now I'm capturing your information based on this structure. And the attribute is an age. So I'm going to write down 18. But what's going to happen next year? Or I don't know if you have a birthday this year, but your age is going to change. So if I added the age, I'm going to have an 18 and I'm going to need to update that. Okay, we clear up to that point? Now, if I ask your birth date, what's your birth date?
October 22.
October 22nd, 2003. That's different because if I ask your birth date, I don't need to worry about the age. I can calculate the age as an operation in the database.
Marco, that is why they ask us to go to CASE every year to corroborate, because a direction is not fixed and a phone number.
Yeah, there's things, that's a good observation then. That's why, and this is not just at CETIS, it's everywhere. If we had have a database of US students, there's certain things that I don't need to ask you. If I ask for your birth date, I don't need to know your age. I'm going to know that. But what Daniel is mentioning is important. You guys give us your address, your email, and your phone number. And we need to be able to contact you. So if you change phone numbers, if you change addresses or emails, or your parents change that, then I'm gonna have problems contacting you. That's why I don't know if you guys are using it or not, but right, that's why the tendency has been for you guys to use the institutional email. Because that we know that that's not gonna change, okay? But that is why there's always this campaign of CASE for you guys to update your data periodically. Because if you don't do that, we don't have a way of knowing that things have changed, okay? If we're talking about a course, well, the course could have an ID, the name of the course, the hours, the units. Maybe the course has laboratory work or not. Maybe the course is taught in English.
The credits,
The credits of the course. If we're here in Mexico, the credits is going to be a fixed value, but if it's in the United States, there's going to be a 2-credit course, a 4-credit course, etc. So the credits might be important as well. Those are examples of attributes. There's going to be certain guidelines as to establishing attributes. But the idea is, again, for those attributes that we need, those that we think about, those that we might need, and attributes that make sense when we're defining. And the other is that we want enough attributes to be able to clearly describe the properties of the entity and be able to differentiate it from other entities. For example, if I'm not mistaken, well, no, I'm not mistaken. Here in the database here at CETIS, we store the information of you as a student, but we also store the information of your parents. So your parents, that can be an entity as well. And it might have most of the same attributes, but a parent isn't going to have a student ID. But a parent might have one of the attributes of the parent might be where they work, for example, and the work information and phone number, address, etc. So certain entities might have very similar attributes, but we have to be able to differentiate. Okay, now something that we didn't specifically talk about when we were talking about entities, and it's a step that we need to do, is to identify what's called the primary key.
That's
for
more
each
specifically for like actual databases, right?
Excuse me?
That's more specific for actual databases, right?
Yeah. So right now we're defining a more a term that's a bit more technical. It's more of an IT term, which is a primary key. What is a primary key? So we've got the attribute that's the student, for example. So how do I differentiate Ana Sancido from Ana Acosta? Well, we call one Fernanda, the other Ana. But let's say that both of them are named Ana. They have different last names, but there might be a situation where we have two people that have exactly the same name. And I think I mentioned the example of myself. There's more than one Jorge Sosa Lopez, at least in Mexico. At least I know one of them worked in a shrimp boat in Ensenada. And I think another one won a race, a marathon. That was not me. There was a Jorge Sosa Lopez that won a marathon in DF. I can assure you completely that was not this Jorge Sosa, unless it was maybe a virtual marathon in a place. But even those, I wouldn't have won. So there might be people with exactly the same names, living in the same address with the same birthday. It's possible. It's improbable, but it's possible. So I need to be able to differentiate you guys. So what happens here? You have student IDs, your matriculas. A student ID is unique. There shouldn't be, well, actually, Luis Gallardo, are you there? Luis Gallardo, birthday?
Yes, teacher. Yes, teacher.
Remember that you had a problem with your student IDs?
Yeah, I had 2 IDs.
Could you briefly remind us of that situation?
Yeah. I didn't pass a subject from the high school, so I needed to, if I wanted to be in CETIS here in the university, I needed to have that subject approved,
Mhm.
but I didn't, so I couldn't be in university with this new or with this old student ID, because that student ID was still in high school, so I needed to change to another new student ID. That's it. I was already in university.
Yeah, so the situation with Luis was interesting because he was coming from CETIS. So your student IDs don't change here at CETIS for any of the levels. So if you're coming, my student ID is 11333. 11333. That was from high school. It was when I studied here engineering. And actually when I also did a master's here at CETIS, it was the same student ID. But what happened with Luis is that he was finishing high school, but he had a course that he needed to finish. So technically his student ID hadn't finished high school, so it can be enrolled in undergrad. So in the meantime, they created a new student ID for him. That was another Luis Gallardo, that was the one that was studying a global program. That generated a bit of a confusion there. But ideally, that situation shouldn't occur. A student should have a unique ID that differentiates them from other students. Actually, what I just said applies to Luis's situation. It's not that there were two Luis Gallardos. It's that there was the Luis Gallardo that was studying high school and the Luis Gallardo that was studying the global program. Both of those can't coexist at the same time. That's why there were two student IDs or two instances. But the student ID is something that's going to uniquely identify students. That's the concept of a primary key. A primary key is going to be an attribute. It's one of the attributes that we already have. In some cases, we don't have the attribute and we need to add it. It's going to be an attribute, or by the way, it can be a combination of attributes as well. It could be one attribute or a combination of attributes that uniquely identifies an instance of an entity. If we don't have a primary key, then we're in trouble because we're not going to be able to differentiate one instance of the entity from another. And that's going to generate anomalies in the database. So for each of the entities, we need to identify their primary key. So for example, for student, the primary key is student ID, or could be the student ID. For a course, the primary key could be the course ID. Notice the term ID. It's very easy to create a primary key for an entity. If I don't have it, I'm just going to add an ID to or a number or an identifier to it. And even some database systems automatically add that if we don't have it. There are going to be some entities that don't have a primary key. Those are called weak entities. Okay. But by correspond, what would a strong entity be? Well, a strong entity would be one where we can clearly identify a primary key as one of the attributes. So a weak entity is one that doesn't have any attribute or combination of attributes that can uniquely identify its instances. Usually what happens with a weak entity is that the weak entity is always going to usually depend on some other entity to be able to identify. So for example, employee children. I'm an employee here at CETIS. My employee number is 72263, and I have two children, Sarah and JD. And so they're associated to me here at CETIS, but they don't necessarily have IDs or identifiers. They're associated through me, but there isn't an employee number for Sarah and an employee number for JD. Okay. The children entity is a weak entity. By itself, it doesn't have attributes that can be primary keys. They have to be related through another entity. Okay, so to wrap this up, we are going to go back to the Sosa Corp example. Remember that Sosa Corp was this company that did things, offers services in a global footprint. It had departments, it has employees, it has projects. Employees work on projects, employees are assigned to departments. employees can manage departments and employees can supervise other employees, and employees have dependents. The problem definition, as we had originally seen it, already identifies basically the attributes. Because in each of the descriptions there, it's telling us how each of what we identified as entities was characterized with regards to their attributes. And so we had gotten up to this point. We had identified 4 entities: employee, department, project, and dependent, and we had identified the relationship. We'd already gotten to that part. An employee is assigned to a department, employee manages the department, an employee supervises another employee, an employee works on a project, has dependents, and a department can manage a project. Those were the relationships that we established. We had already gotten to that part. Let's do the rest of what we've talked about up to this point, which is identify the cardinalities, identify the attributes, and the primary key. And so we're gonna do these. I said that we're gonna do these in houses, but we're gonna go through them here. Because you guys are actually gonna do some exercises, or we're gonna do some more examples, go deeper on these examples later on. First off, employee is assigned to a department. That would be an N-to-1 or a 1-to-N, depending on where you're looking at it, relationship. How many employees can be assigned to a department? 1 or many. How many departments can an employee be assigned to? 1. So that's a 1-to-N relationship. An employee manages a department. That's a 1-to-1 relationship, because 1 employee can manage a department can only be managed by 1 employee. An employee supervises another employee. How many employees can supervise another? How many employees can supervise another employee? I can have no employee supervised, or 1 at least. How many employees can have other employees under their supervision, where I can have 0 or I can have many? An employee works on projects. An employee can work on many projects, and a project can be worked on by many employees. That would be N-to-N. An employee has dependents. How many employees can be had by a dependent? How many? Yeah, so a dependent, a child. How many employees can it be related to if it's a child or a spouse? Well, 1. And how many can an employee have? It can have 0. He or she can have 0, or can have up to N. So it's a 1-to-N relationship. A department manages a project. 1 department can manage many projects, but a project can only be assigned to 1 department. And so the cardinalities are defined as such. So now we have the relationships and we have the cardinalities. That's the 3rd step. The 4th step is to identify the attributes, and the problem definition already gave us those. An employee has a social security number, a name, an address, a salary, gender, birth date, status, if they're a manager or not, and the start date, if they're a manager. A department has a department ID and a name. A project has a project ID and a name. We can add more stuff there if we wanted to. And a dependent has a name, a gender, and the relationship. The relationship is are they your children, your spouse, etc. Those are the attributes. Those are given by the problem definition. In the definition of the problem, we're given those. When you guys do your application project, you're going to have to talk to people in the organization so you can clearly identify these. Well, first off, the entities and the attributes that you're going to be needing to use are making sense. Now, the last or next to last step in this process is to identify the primary keys. So let's do that exercise here. In the case of employee, what would be a candidate for a primary key of the attributes that we have there? Well, not name, because we can have people with the same name.
Security number.
The social security number would make more sense, because people should only have 1 social security number.
But they can still
Well, yeah, we're talking under
That's
normal situation, but yeah. They can steal it or EAMS could make a mistake, which is what happened with me, that I was assigned a social security number of a person that already had one when I did my internship. And that's a real headache to fix. It's a real headache to fix, and at least here in Mexico, it generates a domino effect. So when did this generate a problem for me? It generated a problem for me when I had to enroll in my Afore. And the thing is that when I wanted to get a credit to buy a house, somehow here in Mexico, the information of the Afores is linked to your Infonavit, your house credit information. So if I didn't solve the problem of two Jorge Sosas existing with the same social security number, I was not going to be able to buy a house. So that was a big headache. Department, what would be a candidate for a primary key for the department? Yeah, the ID, that's. And notice that a very simple solution to a primary key is to just place an identifier in the entity, a consecutive number or something that's gonna identify it. For the project, obviously we have the project ID.
When it's a weak entity, like a dependent.
Yep, that's we're getting there. So that's a good observation, Marco. Dependent is a weak entity. Why? Because the name can't be a candidate for a primary key because I can have people with the same name. The gender, it's the same thing in the relation. By the way, this is actually just a note about the name. In my daughter's kindergarten, there are more. There's I think three kids in her group that are named, 3 or 4. They're named that have the same name, the first name. They're named Renata. So my daughter, you have to be very careful with kids when you say, because I joke with her a lot and I say, well, what Renata did you play with today? Was it Renata 1, 2, 3, or 4? I started saying that to her. And she started understanding that that's the way she should identify her friends. So she actually did a drawing. My wife and I were laughing because she did a drawing at school about, they asked her to draw something that you like. And she drew that she was playing with one of her friends. And she actually wrote down that she was playing with Renata Dos. So her identifier was a consecutive number with, and she literally doesn't know the difference. It's like, who did you play with? Oh, Renata 1 is the short one. Renata 2 is the one that likes this, and Renata 3 and 4. So it could be the same names. So the dependent is a weak entity. So you were going to comment or ask a question before I interrupted you.
Yeah,
So go
it's
ahead.
about that. What do we do if there's no key?
There's a couple of things that we can do. The very easy way of solving this,
Is getting an ID.
just adding a so yeah, we're gonna say that we're gonna put here a dependent
For example,
ID.
in the dependent one, my dad works at the hospital, so we are affiliated to the healthcare.
Uh-huh.
So we have our cards,
You have your
but
card.
our cards are his matricula and then underscore and
The other one, yeah.
2 or 03, depending on who is the dependent.
That's the second avenue. That's gonna be a more systematic solution that our database design is gonna take us there. So one solution, Marco, is I'm just gonna add an attribute. I'm gonna add an attribute because I can do that. I'm gonna add an attribute that's gonna be the ID. That's an easy solution, but it's gonna generate a problem because I'm gonna have to be creating a specific number for each of these.
No,
And that might even be confusing.
and that's a problem because they're dependent. So if they're individual, so let's say, because I'm with my dad, it's like a root. So it goes from, if you cut my dad, you cut us. If you
Uh-huh.
cut the employee, maybe the dependent is still there because there was a problem
Yeah,
with that and.
the dependent ID solves the problem for the entity, but it doesn't really solve the problem for the whole database. So what we're gonna get to in what's called the relational model, we haven't got to that part yet, is after we finish this design, there are gonna be certain relationships, mostly the end-to-end relationships and the weak entity relationships that are going to create the situation that Daniel just mentioned. What's actually going to occur is that
Ramificaciones.
if we design the database correctly according to the rules, what's going to happen is that this entity, there's going to be a new entity created by the relationship between the employee and the dependent, where there's going to be a combination or a creation of a new primary key. That's the combination of those two, which is actually what Daniel is saying. It's actually going to be maybe the social security number with a consecutive that identifies the children or the dependents.
They
So
actually cut me last week because I'm,
now you're old enough to not be a dependent. Yeah.
so now I need to be with us as a student.
Yeah, technically, that's why they're called dependents, because at a certain age.
And I need to go every year with a carta that says I'm studying for them to give me.
Yeah, yeah, so I always joke with dependents because it's like in this term, technically dependent, my wife is a dependent. But that's kind of like an old concept where you have a husband and a wife, so one works and the other doesn't, and that's why there's a dependent relationship. But I always joke that I'm actually the dependent because my wife makes more money than me, and I'm really happy about that. And so yeah, the concept of dependent, that's why it's called dependent, because one depends, a child depends on parents.
Yeah,
That's why it makes
my
sense.
guy, like, he still depends and.
Yeah, but you're 18, even if you're 18, you're still dependent, right? But there's legal stuff there. So right now, up to this point, the only thing we're gonna do is identify the weak entity. Up to this point, we're only gonna identify it. The rest of the database design is gonna automatically solve the problem of identifying that or having that relationship. But for now, this is a weak entity that doesn't have a primary key associated. And so these would be the primary keys and the weak entity. Right now for these examples, this is a very simple example. The primary key is just one attribute. We're gonna see certain situations, again, where certain relationships, the end-to-end relationship is gonna create another table or entity that combines attributes to generate a composite primary key, but we'll get to that further on. And there might be some situations where the primary key could be a combination of attributes, and that's also valid. Okay, questions up to this point? Okay.